This tutorial is going to be a quick explanation of the naming system in general or in organic chemistry. And the main thing that we want to first and foremost outline is that we have different naming rules depending on different compounds and their components. And while the rules obviously do differ, there's a way to simplify them so that it doesn't have to be as difficult of a process to try to understand how to name a particular compound. So the first thing we need to think about is whether our compound is an ionic compound or a molecular compound. Ionic compounds contain a metal and a nonmetal. Molecular compounds contain only nonmetals. So that's probably the biggest distinction. It's the easiest point that we can make in this tutorial, and it's probably the most important because this is usually where students have trouble in naming because they confuse the terms and they name an ionic as a molecular and vice versa, and they just get the rules mixed up. So first and foremost, let's go through ionic naming rules. Again, if you see a metal present, you have an ionic compound. And then these three variations of ionic compounds are the most commonly seen. So let's take a look and see what the rules are. The general pattern for naming an ionic compound is name, stem, ide. In an ionic compound, the first element written in the formula is always the metal, the second is the nonmetal. So the first is the cation, the positive charge, and the second is the anion or negative charge. And so what we try to do here is say, all right, if we have a metal-nonmetal combination, we'll give the name of the first element in its entirety, then we'll give the name of the second one as a stem, and then the suffix is always ide. So it's a name, full name, stem, ide. Name, stem, ide. So here we go. A regular binary compound has a main group metal. That means the tall columns on the periodic table means that we give the metal name, this non-metal stem, and ide. So again, name, stem, ide. And again, the metal is always first, and then the non-metal stem. So NaCl is name, sodium, stem, chlor, suffix, ide. Sodium, chlor, ide. Name, stem, ide. In the case of a binary compound that contains, of course, a metal, a nonmetal, again an ionic combination, but uses the short columns that contain metals, the transition metals, or sometimes we call them variable charge metals, we need to actually follow the exact same pattern, but we have to give the charge of the metal, because we don't always know it. It's not a fixed charge like in the main group metals where we always know the charge, but in transition or variable charge metals, as the name would indicate, they are always in transition from one charge to another, or they're variable in charge. So we need to make sure that we give the charge of the metal in the name, and that way when we read the name we know which version of that metal we are actually using in this compound. So again, it's a name, stem, ide with a charge. Metal name, give the charge so we know which version. Non-metal stem, suffix ide. So name with charge, stem, ide. Here's iron oxide, as we would just read it, but because iron is a transition metal, we need to give the charge of iron. Since this is a 2- oxygen, this iron must, of course, then be a 2+ to balance it. So we know this is a iron 2+ version, or iron 2. So we would say name and charge, iron 2, stem, ox, ending, ide. Name, stem, ide with a charge. Iron 2, ox, ide. Last but not least is when you have an ionic compound that contains a metal and a polyatomic ion. So your polyatomic ions are like your hydroxides and your nitrates and nitrites and sulfates and phosphates and so on. So it's important to obviously know the names and formulas and charges of those. If you don't know that, then there's no point in trying to name it. But that's the most difficult part, is memorizing those polyatomic ion formulas and names, because the naming is very simple. You simply write what you see. You give the metal's name and the polyatomic's name. Simple as that. Sodium and hydroxide, NaOH, name of the metal, sodium. Name of the polyatomic, hydroxide, sodium hydroxide. The name of the metal here is aluminum. The name of the polyatomic is phosphate. It's aluminum phosphate. It doesn't really matter if this was, for example, barium hydroxide, and you had 2 of these hydroxides, and this was like such. Let's fix that. It would just be barium hydroxide. If you noticed here, we have not alluded to the fact of however many of these compounds, or how many atoms we have in these compounds. Again, had this been, let's say, magnesium chloride, and we had this, it would still be just magnesium chloride. There is no need to say how many of these you have, and that's probably the number one mistake students make, is always giving the mono-di-tri indication of numbers of atoms in an ionic compound. Where you see a metal, you should never see a Greek prefix to tell you the number of atoms in the compound itself. Very rarely do we see that. So let's move on to when would we use those Greek prefixes? We would use them in molecular compounds. Molecular compounds contain 2 nonmetals, and in that case then we would obviously list the positively charged nonmetal first and the negatively charged nonmetal second, and we would still follow the same name, stem, ide, whereby you give the full name of the first nonmetal, the stem of the second nonmetal, and ide. The only thing is that we have to just say how many of each we have. So we'll say the number of atoms, then the name of the first, the number of atoms, the name of the second, in a stem form, and ide. So name, stem, ide with some numbers mixed in. Number, name, number, stem, ide. The only exception is for the first atom, do not say mono, thereafter you can. Here are the Greek prefixes, mono, di, tri, so on and so forth. Here is N2O4. So 2 N's, 2 is di. Full name of N is nitrogen, dinitrogen. 4 of the oxygen is tetra. Stem is ox, ending is ide. So again, number, name, number, stem, ide. It's still the name, stem, ide, but simply all we do is make sure we have some numbers in front of them. And last but not least are the acids, and the acids are the ones that do give people fits, but again, you will look at an acid as, of course, a compound containing hydrogen as its main cation. And you will see if the hydrogen is paired up with just a regular old nonmetal, like let's say HF or HCN or something like that, or if it will be, or rather than HCN, let's say HCl, or if the H will be paired up with a polyatomic like NO2, or if it's paired up with a polyatomic like NO3. The reason why we decipher them is if you add, let's say we call this F. We'll call this that we have fluoride as our ion, so HF. If an element or nonmetal is all by itself, it will always be an ide. That would be a fluoride ion. If you have a polyatomic that has the lesser oxygens, it's called the ite ending, like this would be nitrite. And if it has more oxygens, it's the ate version, or nitrate. The reason why this is important is because based on the endings is how we're going to name this particular acid. We will first determine what the suffix is, and then of course drop it in favor of something else. So the suffix of ide will drop the ide, the suffix of ate will drop the ate, the suffix of ite will drop the ite, and in turn we'll add something else. For the ides, like let's say HF, HCl, anything along those lines, we would drop the ide, add a hydro at the beginning, the stem of the nonmetal, ic, and acid. If we have a polyatomic that ends in ate, we'll drop the ate and instead use the stem of the polyatomic and add ic and the term acid. And if we have a polyatomic ending of ite, we'll drop the ite, use the stem of the polyatomic that remains, replace the ite with an us, just as we replace the ate up here with an ic, and add the term acid. So again, we'll drop all the suffixes, keep the stems, the stem of the nonmetals, the stem of the polyatomics, and drop the ending. Add a new ending, ic for the nonmetal, ic for the ate ending, us for the ite ending, and of course the term acid. There's nothing else to do except here with the ide ending, we also have to add a prefix, which is hydro. And here are some nice examples. This is a chloride, just a regular Cl, nonmetal by itself. So we would drop the ide and keep the stem, which is chlor, add the new ending, which is ic, and of course acid, and add our prefix, which is the only time we add a prefix is for just regular nonmetals. Let's take a look at this HClO3. ClO3 is the chlorate. So let's drop the ate, use the chlor, stem, add the new suffix of ic and acid, and we've got chloric acid. And HClO, ClO is hypochlorite, drop the ite, keep the hypochlor stem, add your new ending, which is us, and of course acid, and you've got hypochlorous acid. So it just takes a little practice, but with a little practice and keeping the rules straight, hopefully naming won't be such a daunting task anymore.